lungs and see how they performed. And they make 3 groups on a pig model, preserving lungs at 10 degrees, 4 degrees, ice preservation, and they made another group just for a minimal cold ischemic time. And what they saw is same thing. Lungs at 10 degrees, they have better results. If they compare to even the minimal CIT or the cold ischemic time very short, they were not good as well. Like if you compare to the 10 degrees, they are similar to the ones that were preserved on ice. And you can see that on the PF ratio too. And that means that the 10C preservation leads to the initiation of a reparative or protective metabolism process depending on the mitochondrial status, which is quite similar to the mammal hibernation works in, as a natural model for lung preservation. It's like the lungs were hibernating for that. And what are the implications of all these? You know, like be able to store lungs on 10 degrees, but have a cold ischemic time for longer. That can overcome distant barriers. We can do different testing on the lungs and maybe find and choose the best recipient for that lung, because now we have time, don't need to rush. Patients can get desensitization protocol, you know, treatments before being transplanted. And quite interestingly, like we can avoid overnight surgery, you know, which I think is one of the big problems for transplant surgeons. And of course, get the institutional and human resources benefits on all this. And of course, when we say about doing surgeries at night or not, we know that it's shown that overnight transplantations are associated with lower survival rates, which preserving lungs and having the surgery start in the morning is not making the whole health system and all the team, you know, like better or better rested, but that is giving better results for the patients. And that led to the next phase, which is static cold storage on a fridge at 10 degrees, and that was a non-randomized clinical trial. That the whole idea was to get lungs that were cross-clamped after 6 p.m., put them on ice, bring to the hospital facility, put them on the fridge, and get that surgery started in the next morning around 6 a.m., which to respect a 12-hour ischemic time. And that was done, you know, against just the gold standard current practice with ice. And what it showed that if you see on all these, this study was done by Toronto, Vienna, and Madrid. There were like 140 patients matched control to the 70 patients that were done. And the incidence of PGD was the same. There is no more PGD. There is no more complications related to longer preservation. And you see, like when you can extend the preservation time and you have ex vivo lung perfusion, then come and for how long can we keep those lungs alive? And this is a study that was done in Toronto that they were able to preserve a lung for 3 days. They were cycling normothermic ex vivo lung perfusion, like the ex vivo and 10C, for 3 days, got those lungs transplanted. That was in a pig model. And you can imagine, you get lungs for 6 hours on ice, and then 18 hours on 10C, and then you do 4 hours of ex vivo, and then 20 hours of 10C, and then back to ex vivo, back to 10C, and transplant. All the results show that the lungs were able to be sustained for 3 days, and how that is translated to what we have now is that now we have non-portable devices and portable devices that can actually preserve lungs at 10 degrees, which extending our lung preservation times. And having a portable strategy would just go for the next step, which is do a multi-center randomized clinical trial to actually see if the 10C versus ice, if there's no inferiority on those use. And the University of Miami in the MTI, we're part of this trial at Jackson. And it's pretty much a randomization 1-to-1 that lungs that will be accepted for transplant, it's randomized to either the export device, which is the portable device at NC, or just the current ice. We were the first center to use the FDA-approved 10-degree in United States. And that allowed us, for that patient, to have their transplant done with 15 hours of preservation lung. And it's a very interesting concept that we start to bring that make the lung transplantation a semi-elective procedure that is actually benefiting the patient more than actually rushing to the OR to get the lungs transplanted right away. And if we get from the last consensus from 2024, it's in 100% consensus for the panel that studies that are investigating that 4 degrees and 10 degrees can support what has been done, that warmer temperatures would be safe for lung transplantation. I think in conclusion, you can see that, like after the ex vivo lung perfusion, I think the hypothermic start preservation at NC might be the biggest change that is going to happen for the transplant community. Of course, there is an understanding about the mechanism, but there is a lot of other preclinical evidence that can support that, and that makes the clinical results more positive and make the transplant community more inclined to do that change more strongly. And that is going to change and make like real milestone changes on how, on the logistics impact and clinical use is going to be from a patient perspective, health system perspective, and even the organ utilization with these new changes that are happening. I think that is going to be happening like all around the world. Thank you.